Everyone, this is Christine G, and I am going to be going over this problem, and hopefully this makes sense to everybody. Here we're given some data, and then these graphs, and we're asked to match the data set up with the correct graph. So here we can click into the data set, and it's not that many data points. So here we can click it into StatCrunch by clicking that square, and then we can graph it. And this would be a scatter plot that just gives us a bunch of dots, like the graphs at hand. And we just have X and Y for our different columns. And then you'll notice that the graph doesn't start at 0, 0 like the ones in the choices. So you want to kind of note that. So, you know, it could start over here at 6. I don't know why StatCrunch does that, but it does. Anyway, so let's just examine some points and try and figure out which one matches up correctly. So here, this looks like it's almost at 1, and then the value for y is 6. So let's look at if we can eliminate anything here. So 1 and then 6. Gosh, it's hard for me to see, but that looks about right. That looks about right. This looks too short. 1, 2, 3, 4. 1, 2, 3, 4. So we have A and B as our contenders right now. So we can examine some more points on here. This looks like, and we can always make these bigger, by the way, by just clicking that magnifying glass. So this 7, and then this looks like 8 and 9 for the x values. So we have the point 7, 8 and 7, 9. So let's look for that in one of our stack. So yeah, there we go. So B would be it, because you can see A doesn't have, it has 7, this looks like about 4. So we're going to go ahead and choose B, see if that's correct. Good. Then we're not doing this by hand. We are using our friend StatCrunch, and let's go ahead and we just go into stat. We already have the data loaded. And we can go in here and summary stats and then correlation. And then we want to make sure we choose both of these. On a Mac, you hit the command button, or on a PC, shift or something to make sure you get both of those. That's what's needed. And then it computes it automatically. So 3 decimal places, so 0.061. And this is the correlation coefficient, and this tells us how close the points are all to being linear or making a line. And 0.06, the closer it is to 1, you can think of, I often tell students, think of money. The closer it is to like either like a dollar or a negative dollar, the closer it is to looking like a line. And you can see this is scattered about. It doesn't look like it has a linear pattern. And this is like, you know, far away from a dollar. The 0 would be at, you know, you probably wouldn't have, I've never seen one that had absolutely 0, but this is 0.06, so it's like 6 cents of a dollar. It's far away from being linear. And then it says, because the correlation coefficient is, and it is positive, in the absolute value, correlation coefficient, so that is just 0.061. If you had a negative number, you'd put negative in there, and then you'd put the positive value in here. You'd just, if it was negative 0.061, you'd just put 0.061 here. And then we're going to have to use this because of the way things are done here in for the answers. Let me go ahead and first point this out. The data set, there are 5 data points, 1, 2, 3, 4, 5. So when we go into this critical value table, That is our sample size 5. So the correlation, critical value for the correlation coefficient is 0.878. So here, so it's asking, is this greater, the 0.061? Let me put the 0.878. So 0.061 is not greater than the critical value for this data set, 0.878. And it is no linear relationship exists between X and Y. The 0.061 is very far away from a linear pattern, and it's not greater than the 0.878. This would have to be smaller. So I hope this makes sense, and let me check my answer. And let me know if you have any further questions on it. Thanks for